Okay, so let's go to see all the questions in the midterm exam. So this would be the questions. The first problem is trying to find out the definitions of the horizontal line, vertical line, and the angles. We also have another questions to show you how to use this information for the calculation of distance. That will be the problem 5. I will introduce that one later. So for the first one, the problem will consider the Earth's surface as the spheroid, and we have the point A located at the surface of the Earth, and there's one point P, which is about the ground. And the problem wants us to draw the horizontal line and the vertical line or crossing the point A, and also describe the relationship between the horizontal line and the vertical line. And the second problem wants us to find out the vertical angles and the zenith angles for the line for direction from A to B, from A to P. So first, for the horizontal line. Based on definition, the horizontal line would be in a line that will be tangent to the surface of the Earth. And here we want to find out the horizontal line crossing the point A, which means that you need to draw a line that is a tangent to the surface of the Earth. And it will also, the tangent point is just the point A. So this is the horizontal line. And the vertical line, if we have already found out the horizontal line, then the vertical line would be very straightforward, and it's easy for you to identify their relationship. Basically, for the vertical line, you just need to connect the center of the Earth, which would be point O, and the point you are trying to identify. So connecting point O and A and extend this one, this would be the vertical line. And of course, for the horizontal line and the vertical line, we know their relationship is like the horizontal line is always perpendicular to the vertical line. You can use this symbol, or you can just describe that these two are perpendicular to each other. And that's the solution for the first one. Horizontal line is 1 point, vertical line another point, and the relationship, the third point. For the second problem, the vertical and zenith angle. So first of all, you need to draw the direction from point A to P. So we have the direction from A to P. And then the vertical angle, which will be the angle between the direction and the horizontal line. So this is the vertical angle. And the second one would be the horizontal angle. The horizontal angle is just the angle between the direction and the vertical line. So this is the zenith angle. As long as you can identify these two angles, you will get the full point of the second part. So that's the first questions. I will just go to check what's the questions that you have, what's the problem you have for now. There's one question about the whether we need to go through the point O. It's not necessary, as long as for the vertical line, you just need to go through point A, but you have to make sure that they are perpendicular to each other. And if we do the extension of the line, you should cross the point O. Yeah. So if we say that they are perpendicular to each other, then that'll be safe for you. Okay, so that's the first problem. Any questions so far? Okay. If no, we will go to the next question. In the next question, you are provided with the several measurements about the Young's modulus, and we want to find out the mean, median, and the variance of this set of the observations. And in this problem, we actually have, if we count the number of the observations, we have 1, 2, 3, 4, 5, 6. We have n equal to 6. We have 6 observations. And for the first question, the mean, which is the average value of all the observations, this one is very straightforward. So for the mean value, x bar, this will be for point A, would be the summation of xi divided by n. This is the definition of the mean, and this this one should be from I from 1 to n, xi divided by n. And we know that n is 6, and we have all the values. So 116.4 plus 115.9 plus 114.6 and 115.2. So this is the formula for you to calculate the mean value, and the result would be the summation is 737.9 divided by 6. That would be 123.0. You can round this one to 1 digit after the point, or you can have more accurate result. It doesn't matter. This would be the roughly estimation about the result. And so that's the first one. And for the second problem, we want to find out the median. So to calculate the median, what we need to do is that we first need to sort the sample from the lowest value to the highest value. For all these 6 values, I guess this is not the right. So for the first one, we need to find out the smallest one. If it goes through all these 6 values, the smallest one would be 114.6, and the second smallest one would be 115.2, and then you can find out all the rest of the values: 115.8, 115.9, and 116.4, and 160.0. And as the total number n is 6, so we will for the median we need to find, this is an even number, so for the median we need to find out the 2 values, the two middle values in this sorted sample. So for the 2 median values, that will be 115.8 and 115.9. So we can find out the median. X median would be 115.8 plus 115.9 divided by 2, which is 115.85. So that's the way for you to find out the median. And this is the formula we have defined for the median. And the last one is about the variance. So for the variance, we have to call the definition of the variance. So we have sigma square equal to the summation of I from 1 to n xi minus x bar. This is the average value. X bar is the average value. Square divided by m minus 1. And we, from the previous calculation, we get the average value is 123. So we have xi minus 123 square divided by 6 minus 1. For the other part, you can use Excel to calculate the result. What I found is 1640 46.21 divided by 5, which will give you the result as 329.24. So that's the variance for all these 6 samples. Any questions for this one? Okay. So I believe let me see, 1, 2, 3, 4, 5, 6, 7, 8. I believe I'm using I'm sorry. I believe I'm using a wrong value from the I probably copied the old version. So I will give you an update about the correct value for this question again. But this is the way for you to calculate the mean, median, and variance. Okay. So that you should follow the same procedure to get the result. You will receive an updated value from the calculation after this lecture. Okay. Any other questions for this problem? Okay. If no, then I will move to the third one. So the third problem, which is the most complicated problem in this exam. So here we assume that we are conducting the distance measurement with a scale tape, and the tape with the standard length of 30 meters at 20 degrees Celsius. And here you know that the standard temperature is 20 degree, and it's found to be 0.001 meters too short under the tension of 5 kilogram. Here, 5 kilogram is not necessary to be the standard tension, and we actually need to calculate the standard tension. The tape is used to measure the freeway segment with the grade of 4 degree and 25 minutes. And the applied tension in this measurement is 8.5 kilogram. And we also know that the measured distance of the segment is 423.71 meters. And the mean observed temperature during the measurement is 28 degree. We also know the features of the tape. The cross-sectional area is 0.06 square centimeters. The elastic modulus is 2.1 times 10 to the power 6 kilogram per square centimeter, and the coefficient of the thermal expansion is 0.0000116 per degree. And also, you don't need to calculate any sag corrections for this problem. So there are 5 questions in this problem. First, you need to calculate the standard tension, and then you need to find out the corrections of the temperature, the tension, and the horizontal distance and vertical distance. So for the first problem, let's see how we can calculate the standard tension. So we know that the length of the tape is 30 meters, but during the in the second sentence we say that during the calibration process we found the tape is 0.001 meter too short with a tension of 5 kilograms. So if we apply, it means that if we apply the tension of 5 kilogram, the correction should be 0.001 in order to make sure that it will go back to the right distance, 30 meters. So with this information, we can actually calculate the standard tension. So with that, we have to record the definition of the correction for the tension. So Cp equal to P minus P0 times L divided by the cross-section area and modulus of elasticity. We know that P is 5 kilogram and Cp is 0.001. So we can the tape is 0.001 meter too short, so the correction should be minus 0.001 meters. That's one thing we have to consider. So with that, we can find out the Cp is 0.001 minus 0.001, and the applied tension is 5, and we don't know the value of the standard tension, and we know that the length is 30 meters, and we know the cross-sectional area. A is 0.06, and E is 2.1 times 10 to the power 6. So with that, we have the values for the bottom. That is 2. So if we calculate this one, eventually you can find out the value of P0 as 5.42 kilogram. So this is the value you have to put in the first part, 5.42 kilogram. So that's the standard tension. And then for the measurement of the freeway segment, we have the applied tension. Let me move to the second one. So for the measurement, we know the length we measured is 423.71 meters. The applied temperature is 28 degrees. The applied tension is 8.5 kilogram. And also we know the standard temperature, T0 is 20 degrees. The standard tension as what we calculated previously, P0 is 5.42 kilogram. And we also know the value of A 0.06, E 2.1 times 10 to the power of 6. And the thermal expansion alpha 0.000116. So with that, we can then calculate the correction for the temperature. So the correction for the temperature is very simple. You just recall the function of the temperature correction. That is alpha times L T minus T0. So with that, we have alpha as 0.000116 times 423.71 times the temperature. Applied temperature is 28 minus the standard temperature, and you can then get the result. You can then get the result as 0.039 meters. So that's for the standard, the correction for the temperature. And the second problem, the third one is for the correction of the tension, which would be straightforward. Cp will equal to P minus P0 times L divided by A times E. So we have P as the applied tension is 8.5 minus the standard tension 5.42 divided by 0.06 times.
Excuse me.
Yes.
Could you go back to the standard tension correction? Because I got 9.2. I'm not sure.
You get a 9.2 for that one?
Yeah.
Okay. Are you using the same formula for the calculation?
Yeah.
Okay. Well, let me just make a quick calculation about it. Just in case that I introduce something wrong about it.
No problem.
Yeah. So let me quickly check it. So the equation should be the right one. Just to make sure that whether I type anything wrong in the calculator, if there's anything wrong, that might be my issue. So 0.001 and 0.06 to 1 30. So this should be this one times this one times this one divided by this. Okay, I guess you are right. I probably made something wrong about the calculation. There might be something wrong about the digits. So the value should be, sorry, I'm sorry, really sorry about it. So the value here is I guess I made something wrong about digits. So this one is a 9.2 kilogram. I guess when I calculated, I put the correction as 0.01. So that's probably the reason. So with that, we will have I'll just make the modification here. 9.2. So with that, we can find out the correction for the tension. I need to do a quick check about it. So, okay. Also the distance for 23.71. So we have the okay, we have the result as okay, the result would be minus 0.00235 meters, and so that's the result for the correction of the tension. And the last thing will be the calculation of the horizontal distance and the of course the vertical distance. So in order to find out the horizontal distance, so this would be D. We want to find out what's the horizontal distance, and problem E, we want to find out what's the vertical distance. With that, we first need to find out the true distance we measured, the slope distance. So we need to use all the corrections from the previous three questions. So we have S equal to the measured distance minus the correction of the temperature minus the correction of the tension. So with that, we can get the result as 223.71 minus 0.039 plus the value we calculated previously minus 0.00235. So with that, we can get the correct okay, 423.71 go to this one minus this one plus minus 0.039. So the result we get is
Excuse me, Professor.
243.673. Yes.
Could you please review how we calculated the normal tension again, or the standard tension of the? Yes.
Normal tension, this part.
Yes.
So so it just in this case, in the first problem, you just assume that this kind of process as in the this is actually in the calibration process to see whether the tape is working appropriately. So we find that the tape is 0.001 meters too short under the tension of 5 kilogram. So it's supposed to measure on the 30-meter distance. So it's supposed to measure on the true distance of 30 meters. But if you apply 5 kilogram, if you apply 5 kilogram tension, there's an error which is 0.001 meters. So this means that the if you apply 5 kilogram to the tension of 5 kilogram to measure the distance of 30 meters, what you will read from the tape is 30.001, and which means that the correction of the tension should be minus 0.001 meters. And yes.
So I guess my question is, when it says it's too short, that I would assume that means that the tension that we applied would be greater than the normal tension.
This is actually the correction process. It's different from the process for you to use the tape to measure the true distance. If you measure the true distance, too short means that you measure the value as 29.99. So that means that it's too short for the true distance. For the calibration process, it's different. It means that you are using the full 30 meters to measure the true 30 meters. But what do you find that you are still lacking of 0.00 or 0.001 meters, the true distance. It's a kind of the tricky part about the calibration and the actual measurement.
I understand. Thank you.
Okay. So with that, we can then get the result. Okay, we can get the result. I guess I placed the wrong sign here. Sorry. For the, I guess I placed the wrong sign here. Sorry. This should be the plus and plus. For the correction, so I will just do this one, and the result would be well, I need to recalculate because I get something I get a wrong standard tension in the previous calculation. So plus and plus. So the result would be 423.775 meters, and this is the true slope distance. And the next thing you need to think about is the next thing is about the horizontal distance and vertical distance. We know that the grade of the slope is it's a 4 degree and say it's a 4 degree 25 minutes, and for the horizontal distance, that should be the slope times cosine theta, And for the vertical distance, now should be the slope times sine theta. So in this case, we will have the slope distance as 423.75 times cosine 4 degree 25 minutes. And here you need to think about how to convert this one to the radian. And the way for you to do that is 4 divided by 4 plus 25 divided by 60, convert this one to degree, and divided by 180 times pi, and use this radian value to apply the cosine function. And with that, you can get the result as, I need to do the calculation again. The distance is different now. So just a moment, let me try to find out the value for degree 25. So this one equals to so the horizontal distance would be the value of the slope times cosine, the gradient, and that will be 422.49 meters. And for the vertical distance times sine 4 degree 25 minutes. So the result would be 32.63 meters. So that's the way for you to get the result. Do you have any questions? So for the there are some questions, some concerns about the marks and the with respect to the values. For all this problem, if we are using the right formulas to do the calculation, and then you won't lose any the amount. I mean the penalty for the wrong absolute value will be very small. You will just take like a 1 to 2 points depending on where you get the wrong absolute value. And also we're going to check the process for you to apply the value. If you get the wrong value in the first step, but all the rest calculation are correct, that should be fine. Okay, so that's the third problem. And if you don't have any questions, I will move to the fourth one. Okay, for the fourth one, first one is about the differential leveling problem. And in this problem, you are provided with the elevation of two benchmarks, benchmark 0 and benchmark 1. You know there are two elevations. One is 26.3 meters, the other one is 28.7 meters. And you have the backside and the foresight of each turning point. And we have to use this information to calculate the elevations of turning point 2, turning point 4, and also find out the measurement error for the whole differential leveling. So for the calculation, we actually need to calculate the elevation of all the points in order to find out the closure error. So what you need to do, like for the turning point 1, well, in the problem, you actually are provided with the backside and foresight. For the turning point 1, the value should be TP1 should be the benchmark 0 plus the backside 0 minus the foresight 1. So what we will get for the elevation of turning point 1 is a 26.315 plus backside 0 is a 2.623 minus 0.963. So we started get the result as 27.975. So which would be the value you have to put for the turning point 1, and you can apply the similar process for the turning point 2. That would be the turning point 1 plus backside 1 minus foresight 2, which would be the backside 1 is this value and the foresight 2 is this one. And if you apply all the values in this equation, you will get the elevation of the turning point 2 as 28.807. So this is 28.807. Again, like in this calculation, in this problem, you don't need to fill this table, but you have to find out the elevation of turning point 1 in order for you to get the elevation of turning point 2. You can get this, apply the similar process for turning point 3. That will be the turning point 2 plus backside 2 minus the foresight 3, which will give you the result as 27.397. This is a backside 2. This is a foresight 3. And for the turning point 4, the similar process will be applied. You will have the result as turning point 3 plus backside 3 minus foresight 4, which will give you the result as 27,486. So you have to put this value in your final answer. And the last one would be the measurement error. The measurement error is determined by the estimated elevation of benchmark 1 and the true benchmark 1. So for the benchmark 1 estimated value would be the turning point 4 plus the backside 4 minus the foresight, I guess foresight 5. And this will give you the value of 28.782. So this is the estimated value, and the error will be the estimated value minus the true value minus the estimated value. So the true value is 28.775 minus 28. The estimated value is 782, and give you the error as minus 0.007, which would be the value you have to present here. Okay, so that's the differential leveling. And do you have any questions? There's questions about the errors. Actually, for this error, we don't need to think about the sign. It could be positive, could be negative. As long as you specify what's the error it is, you might compare the find out the error from the estimated value to the true value, or from the true value to the estimated value. Either way is fine. Okay, so that's the problem 4, and the last problem 5. this is the problem. Like well, in the exam, I specified the settings of the tape in the teams, but some students may not be able to access the team. So if we are not using the features of the tape, like the cross-sectional area, the modulus of elasticity, or the thermal expansion, it's fine. If we don't apply any corrections and you don't use this value, it's fine. Or if you apply some other values, it's also fine. In the teams, I just specified that you can use the value from problem 3. But if you don't use them, that should be okay. So here, in this problem, I want you to do the calculation of the horizontal and vertical distance, and also find out the elevation of one point, and also try to understand the relationship between the zenith angle and the vertical angle. So first of all, we need to do the to solve this problem. If you know the features of the tape, you will need to consider the corrections of the temperature and the correction of the tension. So for the correction of the temperature, that will be simple. There's alpha times L, T minus T0. So alpha is 0.0000116 times the Mayer distance is 165.299. And the applied temperature is 30 degree, and the standard temperature is 20 degree. So with that, you get the result as 0.019 meters. And that's for the correction of the temperature. You can also find out the correction of the tension, P minus P0 times L divided by A times E. So the applied tension is a 5 kilogram, and the standard tension is set as 8 kilogram times the total length 165.299 divided by A is 0.06 times 2.1 times 10 to the power of 6. So this one will give you the correction of the tension as 0.004 meters. And with that, you can find out the true slope, the true distance of the slope. So that is which is also the distance from A to B. With that, we have the L plus the correction of the temperature plus the correction of the tension. So you get the value as 165.299 plus 0.019 minus 0.004 equal to 165.314 meters. So this is the true distance of the slope. And for the horizontal distance, that's a problem A, and vertical distance. Here you are provided with the zenith angle, which is 86 degree, 32 minutes, and 42 seconds. You can also find out, with that you can find out the vertical angle. Theta, that will be 90 degree minus the zenith angle, which you can get the result as 3 degree, 27 minutes, and 18 seconds. And for the horizontal distance, the value is S times cosine theta, or it could be S times sine zenith angle. If we did not calculate the value of the vertical distance, you can use the zenith angle directly. So with that, you can get the result as 165.014 meters. So that's the horizontal distance. And the second one we actually want to find out the elevation of point A, but to find out the elevation of point A, we need to know the elevation difference between A and B. So which would be the vertical distance. So the vertical distance would be the could be the slope distance times sine theta, or could be the slope distance times cosine z, depending on whether you have the value of the vertical angle. And this one will give you the value as the vertical distance as 9.963 meters. And of course, here we measure the distance from A to B. So this is the point A, and this is the point B. And if the vertical angle is positive, means that point B is higher than the point A. This one represents the vertical angle, and this is the zenith angle. So with that, you can find out the elevation of point A. That will be the elevation of B minus the vertical distance. So we know the elevation of the point B is 342.17 meters, and the vertical distance is 9.963 meters. So we get the result as 332.307 meters. So that's the elevation of point A. Okay, I think that will be all about the exam. And as I say that if for the problem 5, if you did not calculate the corrections of the temperature or the tension, or you use the different values for the temperature and the tension, that will be fine. We will not apply any penalty for that. But you need to find out the right value of the elevation. Make sure that the elevation of point A is smaller than point B. That's from the definition of the vertical angle. Okay. Any questions? Any questions about the exam? Okay. If there's any questions,
Professor, I have a question.
Yes. Yes.
So in problem 5, there is no temperature and tension facts. Like we should not do any corrections for that.
Yeah, you are well. In the exam sheet, I did not provide the values of the cross-sectional area or the modulus or elasticity and the thermal expansion. If you in the actually during the exam, I give an announcement for the class. You have to use the value from the problem from problem 3. But if you did not get that announcement and you did not do the correction, that should be fine. But you need to know how to calculate the horizontal distance and vertical distance, and how to calculate the elevation at point A.
So does that mean that if I use the corrections, it should be fine for problem 5?
It should be fine.
Okay.
Yes, you can
Okay.
either use the correction or not. Yeah. Okay. Any other questions? As I say that the exam, the grade exam will be returned to you early next week, and of course I will try to go through every step that you do. You don't need to worry about the absolute values. We will focus on the steps instead of the absolute values. Okay. If there's any other questions, that will be all about the lecture today. Thank you very much for your time. And with that, I will close the lecture today, and I will see you tomorrow.